Hello, 6th grade math students. This is chapter 12.3, where we continue our study of prisms by learning how to calculate volume. Let's begin. Let's begin our study of volume by deriving the formula for the volume of a rectangular prism. When we derive a formula, I'm showing you mathematically why the formula works. So let me work you through the steps, and that will help you understand why the formula is what it is. The rectangular prism shown here is 4.5 inches long, 1 inch wide, and 1.5 inches high. Find its volume. So examining the diagram, we can see that the prism is made up of 4 green cubes, 5 blue half cubes, and then 1 yellow quarter cube. Each of the green cubes is 1 cubic inch, or 1 inch cubed. Okay? That means each of the sides, the length, the width, and the height of the cube are 1 inch long. Knowing that, let's begin to calculate our volume. Each green cube is 1 inch cubed. So we have 4 of those. We have 4 times 1, giving us 4 cubic inches. We have 1, 2, 3, 4, 5 half cubes. So 5 times 1/2 are 2.5 inches cubed for blue cubes. Then we have a 1/4 cube as well. To find the overall volume, we simply need to add all of these together. 4 plus 2.5 plus 1/4. We need to make some common denominators here. If you can do that in your head too, that's great. I'm just going to do it in my head. 4 plus 2 is 6. 1/2 is the same as 2/4. So 2/4 plus 1/4 is 3/4. So the volume of the rectangular prism shown here is 6 3/4 inches cubed. If we were to use the formula, which is length times width times height, let's solve that way and see what we get. It would be 4.5 times the width of 1 times the height of 1.5. All right. I'm going to convert these to improper fractions because that's what I like to do when I'm multiplying. So that gives us 9/2 times 1 times 3/2, which will give us 9 times 3 is 27/4. 4 goes into 27 6 times, remainder 3/4. And there we go. Using the formula, we got the exact same answer. The volume of the rectangular prism is 6 3/4 inches cubed. Let's use the formula to find the volume of this cube, which has a length of 8.4 centimeters, a width of 5.5 centimeters, and a height of 9 centimeters. So I'm using my formula, volume equals length times width times height. I'm taking 8.4 times 5.5 times 9. I'm using my calculator to speed up that process. And my answer is 415.8 centimeters cubed. You should be able to solve any of these volume problems as long as you can identify the length, the width, and the height. Now try these practice problems on your own. Find the volume of each rectangular prism. Just to make these a little easier to see, this is 12 inches, this is 6, this is 5 1/4, this is 8 centimeters, 7.2 centimeters, and 3 centimeters. This is 4 feet, 3 feet, and 8 1/3 feet. Remember, your formula for volume is length times width times height. Good luck. I'll see you in a moment to talk about cross sections. Now let's begin examining the cross sections of prisms. The square prism in this picture is sliced in 2 places. We've cut a line parallel to the bases along segment AB, and we've cut another line along line CD that is also parallel to the bases. Each one of these slices through the solid figure is called a cross-section. The cross-section that we form through line AB is a rectangle, and it's congruent to each base. As long as you slice exactly parallel to the base, the cross-section will always be congruent. Makes sense, right? Because you're essentially just slicing a piece off the top. The cross-section CD is also going to be congruent to each base. It might help to imagine the rectangular prism as a block of wood. If you cut the block of wood exactly parallel to the end, you'll end up with another block of wood that you can neatly stack directly on top of the other. As long as you cut in parallel to the base, you could make as many slices as you want, and they would all be congruent. And they would all have the same basic shape, which is as a square prism. Now let's take a look at a triangular prism. This works in exactly the same way. There are right triangles for the bases, and you can see that along line PQ, we've created a cross-section by cutting exactly parallel through the triangular prism. And we've also made another cut parallel to the base through line RS. The cross-sections are triangles, and they're congruent to the bases. In general, any prism has uniform cross-sections or cross-sections that are the same when it is sliced parallel to the bases of the prism. No matter what the basic shape, this will be true. Here are 3 practice problems for you to try. Tell whether the slices parallel to each given slice will form uniform cross-sections. In other words, if you were to slice these shapes as indicated, would the resulting cross-sections be congruent to the bases? It's a little tricky to see these. It might be a little small, especially if you're watching on your phone or your iPad. So if you can't see it perfectly, just do your best. We'll check them in the textbook tomorrow. Press pause while you work. We have more to learn when you come back. We can use another formula to find the volume of any prism. For the rectangular prism shown here, we know we can find the volume by taking the length times the width times the height. Since length times width is also equal to the area of the base, we now see that we can create a new formula, which is area of the base, which we'll give as capital B, times height equals volume. Let me show you immediately how this can be useful by solving area of a prism with a parallelogram for a base. The prism shown here has bases that are parallelograms. We know the area of a base, it's 20 inches squared. And we know the height of the prism, which is 4 inches. We can use that information to find the volume. 20 inches squared, area of the base, times 4 inches, our height, gives us 80 inches cubed. So the volume of this prism is 80 cubic inches. Now let's try this with a triangular prism. We can calculate the area of the base of this triangular prism by multiplying 6 2/3 feet by 5.5 feet as our base and height of our triangle. So let's use what we know about area of a triangle, 1/2 times 6 2/3 times 5.5 is going to equal our area, correct? So let's go ahead and solve that. It's going to be 1/2 multiplied by 20/3 by 11/2. We can cross reduce to get 1 and 10, and then again to get 1 and 5, giving us 55/3. If we take that, 55/3, as the area of our bases, and multiply that times the height, which is 12, we'll get the volume of this triangular prism. So let's go ahead and quick work this out. Let's cross reduce to get 1 and 4. 55 times 4 gives us 220 feet cubed. So the volume of this prism is 220 cubic feet. And let's close out chapter 12.3 with these last 3 practice problems. Find the volume of each of the prisms shown here. This volume is 9, this is 5.5, and this is 6 centimeters. This is 14, this is 10, and this is 3 1/3. And finally, the height here, if you can see the little green arrow, that's 2 feet. This length is 4 feet. This length is 12. And this length is 10 for this trapezoidal prism. All right, please remember to use this simplified formula. Area of the base times height will give you the volume. Don't forget, area of a trapezoid is 1/2 times height times b sub 1 plus b sub 2. All right, good luck with these problems. They're a little tricky, but I know you can do it. I'll see you tomorrow to do more practice on finding volume. I hope you enjoyed learning this brand new concept today. See you then.